So hello guys, welcome back to another video. Today I'll show you how you can make this cool hand tracking droid using ESP-32 camera module. So let's talk about the component first. For this you need two SG90 servo motors, then you need pan tilt servo bracket which will look like this. You need to assemble it, and after assembling it should look like this. And you at the end you need this ESP-32 camera module with the MB board. So why we are using MB board? Because with this MB board we can program it easily, also we can power it easily. So that is the reason why I'm using this MB board. You can go with any other programmer like Arduino or FTDI controller. Okay, so now since the component list is done, let's move to the assembly. You just need to connect all the servos to some external power source, and after that you need to connect this servo pins to this ESP-32 board. And to connect that to this board, as you can see on the screen, you need to solder 3 more wires. One for ground to connect the ground of the both servo to the ESP-32, and the pin 14 and 15 to the servo motor. So these 3 wires you need to solder to the MB module so that you can connect it to the servo and the ground. Okay, now since after assembling it should look like this, like you are seeing on the screen. After that, just plug your ESP-32 module to your laptop, and let's move to the coding part now. So for the coding part, first of all you have to add these two libraries to your Arduino IDE, async TCP library and async web server library. Both of the library link is on my GitHub. You can just go to it and download it from there. After that you need to go to this sketch and update your Wi-Fi name and the password here. In this code we are doing nothing much. We are starting a web server, also a WebSocket server. So the server is to just to check the connection between servos and ESP-32. I'll show you in a while. And after this we have this WebSocket server that is also needed for the another thing to control the servo movements with the hand tracking. Okay, now you need to do nothing, just connect your ESP-32 board to the laptop. Select in the board, select ESP-32 rover module, and upload speed should be this, and the frequency should be 40, and partition scheme should be UJAP, and the port, select the port whichever port your ESP-32 is connected to. After that just click on upload, but before that make sure you installed both the libraries which I showed on my GitHub, these two. After that just click on upload and press the boot button in the ESP-32 board, and after that just monitor this serial monitor, and you will see the IP here, like you are seeing HTTP server started. You will see the IP here, and note that IP. After that you can disconnect the ESP-32 from this laptop, and you can connect it to some external power source if you want to control it from a long distance. So that's it. Now let's check the connection with the web server which we created. So as you can see, I've connected servo motor and the ESP-32 board, and we have this slider for pan, tilt and light. I am moving the slider and the servos are moving properly. Same goes with the light. So I guess our connections are working. Okay, since our connections are working fine, let's place this ESP board over this bracket, and after that it should look like this. Now after that let's move to this Python code which will be responsible for sending the servo commands according to the hand tracking movement. For this, we are using MediaPipe to track our hand track and detect. If you don't know MediaPipe, to be short and simple, it's a model which is trained by Google, and they have combined it into a module which you can use and directly pass your image to that module, and at the end it will return you the plotted image with the key point location. So that's what we are using. The reason why we are using MediaPipe, because MediaPipe is like faster on CPU and its detection is really good, so that is why we are using MediaPipe. Okay, now let's go to the code. Here you have to replace your IP. For my case it is 67, so I am putting that. After that, we are creating connection to the server which is running on that board. For that, we are passing this IP. After that, we are initializing a URL variable which will be responsible for getting the feed. So for that also we are using this IP. Then this MP detector is a class which is responsible for plotting and getting the MediaPipe points. Just to make it simple, I created a class. You can just go through the code and you'll get it. What are the things I've done? It's pretty straightforward. So after that, we have this object which we'll use later. These required variable, we'll talk about it once it will be needed. And we have this blink function. This blink function is being used when let's say if we are showing any gesture to the in front of camera, that time it will check if the gesture is fist. That means we should turn on the light for 2 seconds. That's why we have sleep timer for 2 seconds, and then we'll turn it off. For that case, we have this function. So for this gesture detection, I've trained one model using TF Lite. So that model is inside the repo. You don't need to go in depth, you can just directly use it, simply plug and play. It's a pretty accurate model for gesture detection. That's what we are using for fist. Okay, now we have old speed, these we'll talk about later. After that, here comes our main loop, while loop, which we usually have for OpenCV, like the endless loop. So it will keep on fetch the image from the URL until we until we press Q. 0xFF means Q key. So until we press Q, it will start. It will keep on fetch, and after that resize that frame, and then pass that to this detector object, and at the end we will get the image that will have the hand points plotted. Label is the which hand it is it left hand or right hand. Landmarks is the hand point location, where exactly they are in the frame. After that, this rectangle is the bounding box around the hand. After that, this hand ID is the gesture which we are showing in front of camera. So after that, we have this buffer. We'll talk about this later. Speed, we'll talk about this later as well. Okay, now we are calculating the center of the frame. Let's say this whole screen you are seeing is a frame, so in this center will be somewhere around here. So that's what we are doing. In that frame which we are getting here, we are calculating the center of that image and saving it into mid-x and mid-y. After that, we are calculating the center of our hand. We are getting a rectangle box around our hand, right? So that rectangular box will have a center. So that center we are calculating and saving it into mid-x mid-y, and center x center y will have the frame center. After that, we are plotting that center just for our convenience purpose. And after that, we have this if logic. For this, let's go to the different code. I'll show you how it will work, this logic. Okay, let's run our code. Okay, for this I'm using laptop camera, but that is fine. Let's uncomment this one. Yeah, okay. Okay, so you are seeing this pink dot. This pink dot is the center of this frame, which we calculated center x and center y. And if I show my hand, you can see this red dot. This red dot is the center of my hand. So we are calculating how far are we from this center. So let's say if we are here, then it is fine. If we are here, then servo pan servo, x is for pan servo will move in the opposite direction. So let's say if we are here, then servo will move like this until we reach this center. Similarly, if we are here, then servo will move in the opposite direction to the left direction until we meet this pink dot position. But again, since this distance is like too small, this area, so let's say if my hand is here, then it is fine. But if my hand is slightly here, then it will start moving like this. Then again, if my hand is here, then it will go like this. So at the end it will flicker like this. That we don't want. So for that, what we will do is we'll create a buffer area. For that buffer area, we have this buffer variable which is 30 is nothing, just a pixel. So if the point is near somewhere around center 30 pixels, then we'll do nothing, we'll count it as that it is in the position. So for that I have created a rectangle to show you the buffer area. So see, this is the buffer area, and if my hand point is inside here, then it will not move at all. As soon as my hand point is like going up outside this bounding box, that time servo will start moving and try to make it inside the bounding box again. So for that we are doing this. So let's say if we are here, then we are sending the servo command. What we are sending, let's go to the if logic. So if center minus buffer x, center x means x here. So center x minus buffer means 30 pixel. That means here, if our mid x is our hand point center x, then if it is smaller than this, that means it is somewhere like this. That time we are increasing the servo speed by the speed value is 5, means by 5. That means if it is 0, then we will move it 5 so that it will go here. So whatever the distance, it will go increase accordingly. Same goes for the y axis. If center y minus buffer, that means this area. If my hand is here in this area, that time it will move like it will go above like this. So same goes for the right direction and the below. So that's the logic which we are using. After that, after getting the position and position y, these two values, we are sending it using ws1, which is which will be having, like we discussed in the code, we have 3 keys, right? Pan, tilt, and let's quickly search. Yeah, pan, tilt, and light. So that's what we are sending. If we are sending position value, then we will be sending it with tilt. If we are sending position y, then it will be like pan. And if we are sending the light, for light we are calling this blink, creating a thread and calling this blink. This blink will send the light with the brightness of something for 2 seconds. Okay, yeah, so that's pretty much of it. This will help you to track your hand, and servo motor will move accordingly. I know it looks pretty little bit complicated, but I would suggest you to go to this Python code and play around with the logic, just to see how it is working and all. And if you want to test it with your laptop webcam or any other webcam, you can use this old main.py to test it out. This is just for your learning purpose. And that's pretty much of it, guys. Hope you guys like it, and please do let me know in the comment section what else you want me to make next. I'll try to make it more in a more simpler way so that you can get it easily. And again, if you don't get the code that much, I would say if you really want to learn, you can just go through this code and play around with the values. And also you can ping me on on my GitHub. I have my contact details, my LinkedIn and my Telegram ID. You can text me there if you want to. If you don't get anything, I'll explain. Otherwise, if you just want to play around and just to create a POC or something like that, then just directly run the code. You don't even need to learn it or go through in depth. Yeah. Okay, so that's pretty much of it. Now I'll take my leave. See you guys in the next video. Till then, bye bye.